Hello and welcome to Pep Talk with me, Mr. Pepperell. Today I'm asking, why is it hard to control a little brush on the end of a long pole? By the end of this episode, you should be able to tell me, what does the moment of a force measure? How can we calculate the moment of a force? And how can we increase the moment of a force?
So there was this guy here, and he was out the window cleaning off the front of school with his enormous long pole. And I watched him for a bit, and he was really struggling with this little tiny brush that he had on the end, which basically had a really, really low weight. So why was he struggling? Well, it's all to do with something called the moment of a force. So before we find out about moments, let's just check out some of the keywords we're going to need. Here we've got an object which is going to be lifted by this lever. Okay, and we're going to bend this lever down to lift this object up off the floor. Now in this setup, I refer to my object as a load, and it's actually just the weight of the object. Now my crowbar turns around a little point just here. This is the bit that's touching the floor. That's the bit that the crowbar is going to turn around, and in this situation I refer to that as the pivot. And finally, the amount of force that I'm going to push down on the top of my crowbar uphill with, that's got a certain name as well. So the amount of force that I apply, I'm pushing straight down on the crowbar, is referred to as the effort. Now, although I'm pushing straight down on the crowbar, this actually results in a turning effect because of the fact that the crowbar's in contact with the floor there, and it's going to turn around that pivot. And the turning effect of that force is actually referred to as the moment. So the moment is a turning effect of a force. So going back to this guy again, if we think about his setup in terms of those words we've just encountered there, in this case his brush at the end is his load, his hands are the pivot because that's where his pole was turning about his pivot, and he's actually providing the effort to try and move the load around. But why did he take such a lot of effort to keep his brush still? Well, the size of a moment is actually the product of two things. Firstly, it's the product of the size of the force that is being exerted and the distance from the pivot that force is actually exerted. So although the load or the weight of his brush was really, really small, it was a long way from the pivot point, and we can actually calculate a moment using this calculation. So a moment is equal to the force multiplied by the perpendicular distance from the line of action from the force. Basically what that means is up here our force was acting in this direction backwards and forwards here like this, and the perpendicular distance is just the distance down here to the pivot at right angles to the line of action of that force up there. So we can use the calculation moment equals force multiplied by perpendicular distance to work out the moment, and of course force is measured in newtons, distance always measured in meters, so a moment is actually measured in a unit called a Newton meter, which is just newtons times by meters. So let's actually work out the size of the moment, or the size of the turning force that is going on in our example here. Okay, I've got my force, which is being exerted by the brush up there, and the brush probably only had a weight of 10 newtons, okay, but it's the distance from the pivot that's important here, and the distance up there, if I estimate it, the distance from the pivot up to where the line of action of the force actually is, was probably about 12 meters all the way up there. So actually the calculation I need to do is the force, which was 10 newtons, multiplied by the distance, which was 12 meters. So you can see the size of that turning effect of the force, or the size of the moment, was actually 120 Newton meters. So let's try that math again. I've got another example here, a similar situation. I've got a hammer being used to pull a nail out of a piece of wood. The amount of force being exerted is 50 newtons. The perpendicular distance from the line of action of the force down to the pivot point is 0.3 meters. Pause this, do the working out for me. Remember, this would be worth 3 marks in the exam, 1 for writing down the formula, 1 for substituting the values in, and finally 1 mark for getting the right answer with the right unit. So pause me, have a go, and then start me up and see if you get the same answer as me. So hopefully you've had a go there, and what we should see is, if we do the working out for this one, we can see that the force being exerted was 50 newtons up here, so 50 newtons multiplied by the perpendicular distance from the line of action, which was 0.3 meters, so it's just 50 multiplied by 0.3 gave me a value of 15 Newton meters. So hopefully you can see what the factors are that affect the size of a moment. Hopefully you can see that if you have a big enough lever, you can move a massive load even with very little effort. And if I want to move a bigger and bigger load, all I need is a bigger and bigger lever. So moments come in really handy for a range of applications that we experience every day, right from opening doors. Okay, this door handle here is a pivot with a lever, and I exert a force on the end of it there, and also for other uses like getting the lids off of a tin of paint. Okay, it's quite a hard thing to do. If I try and do it with my fingernail, I can't do it at all. I can't exert enough force at this point to get the lid off, but with the use of a lever, I'm exerting that force at a distance. So by multiplying the force by the distance, I've got a bigger moment, which is the turning effect around this pivot here, and that causes the lid to pop off. And it's the turning effect of the force that gets the job done.
So that's everything we need to know about moments, how to calculate them, and factors that affect their size. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.